Have you ever found yourself in that situation?
Yeah.
I mean, it happens all the time, right? You start with a clear plan, maybe a project or a new AI you're rolling out. You have these specific goals.
The best intentions.
Exactly. Best intentions. But then time goes by, and what's actually happening starts to, well, drift away from that original idea.
Mm-hmm. That gap.
Right, that gap.
Mm.
It's not just a feeling, is it? Our sources today call it trust debt, measurable misalignments.
Yeah, something you can actually quantify.
Okay, let's unpack this then. Today, we're diving deep into some really fascinating material. It's about a new system called IntentGuard.
IntentGuard, right.
And it promises to measure this exact thing, to bring some, mathematical rigor to this whole fuzzy area of trust, especially with AI and, well, complex software.
Which is everywhere now.
Totally. So in this deep dive, we'll explore the problem itself, this trust debt idea. We'll look at some clever ways they explain it using metaphors.
Which are quite good, actually.
Yeah. Then the math behind the solution, which is surprising. And we'll even get a look at it working, like a live demonstration.
So our mission, really, is to help you understand what this trust debt actually means for you. Why the ways we currently handle AI safety, well, they fall short.
Seriously short, based on this.
Yeah, and how this new system offers maybe a shortcut to getting properly informed about, as they put it, the physics of AI trust.
Physics of AI trust. I like that.
It frames the core challenge, doesn't it? Current AI safety methods, they often lack the formal mathematical properties you need for reliable trust measurement. It's like trying to navigate with just a compass versus having a full, detailed map.
A compass gives you direction, but a map shows the terrain, the obstacles.
Exactly. The precise location. One is helpful, the other is, well, essential for complex journeys. You need the map.
So trust debt. It sounds, important, maybe a bit scary even. How do we get our heads around this invisible force? What is it fundamentally?
Well, at its heart, it's that measurable misalignment we talked about between intent and reality.
Okay, define those a bit more. Intent is
your plan. Your documentation, business goals for an AI, the design specs you started with.
Got it. The should be.
Exactly. And reality, that's the S. The actual code that got written, the AI's real behavior out in the wild, how the system truly operates day to day.
So trust debt is the distance between those two.
Precisely. A quantifiable distance on a kind of conceptual map. It's the quiet buildup of all those little deviations from the original plan, or sometimes big ones.
That makes sense, especially in tech where things change so fast.
Yeah.
And you mentioned metaphors. Our sources use them quite effectively here.
They do. They offer two really different lenses, which I think is smart, both powerful for looking at the problem and the solution.
Okay, let's start with the first one.
The first is the map of thought. This one's very intuitive, right? Accessible. Everyone understands a map.
Navigation, clarity, control.
It has that positive feel, order out of chaos. And what's really cool is how it links to the patents idea.
Okay.
The map is the territory.
Wait, the map is the territory. How does that work?
It means the system itself, IntentGuard, embodies the map. There's no translation layer creating errors. It's a direct link, semantic to physical.
Ah, okay. So the map isn't just a picture of the system. It is a core part of how the system understands itself.
You got it. So IntentGuard is the map provider. Big difference from just having a compass.
But are there downsides to this metaphor? Does it capture everything?
Well, maybe not everything. Its strength is clarity, but it could potentially downplay just how messy and dynamic real AI systems get, high-dimensional complexity.
Right, a static map doesn't really show drift over time or the struggle of keeping everything aligned.
Exactly. It doesn't scream active management needed quite as loudly. Which brings us to the second metaphor.
Okay, here's where it gets really interesting, I think. This one sounds much more vivid and maybe more relatable for people in the trenches.
I think so. It really dives into the technical gnarliness, it's called. Semantic net you need to herd the combinatorial explosion cats.
Uh-huh. Okay, wow. Break that down. Herding cats, I get impossible task.
Right, and semantic net, that's an AI term. Think of it like the AI's knowledge graph, this huge web of connected concepts and data, super complex.
So you're trying to manage this giant tangled web like herding cats.
Exactly. And then combinatorial explosion. That's about the complexity just ballooning exponentially. You have all these interacting parts.
And a number of possible states just goes through the roof, unmanageable.
Precisely. This metaphor, it hits home for technical folks. It shows you understand their struggle. It nails the dynamic, chaotic reality and the need for active management.
But the downside, Probably not great for the boardroom presentation.
Probably not, yeah. It's jargon heavy. Herding cats explosions sounds a bit negative, maybe overwhelming. It lacks that simple aha of the map.
So, two very different metaphors. Which one should people use?
Well, what's fascinating is the recommendation. Use both. Tailor it. The map of thought for the big picture, the high-level story.
For executive, maybe investors.
Right. And the herding cats for the deep dives, for the technical teams who live that complexity.
So you get clarity and you acknowledge the real difficulty. Smart.
It lets you communicate effectively with everyone involved, respecting both the goal's simplicity and the challenge's complexity.
Okay, so if the problem is like herding these combinatorial explosion cats, and the goal is that nice, clear map of thought, how do you actually build the map? This gets into the solution, right? The math.
Exactly. And this is where IntentGuard claims its real innovation lies. It's not just another tool slapped on top. They argue they've found 3 mathematically necessary properties.
Necessary. Not just good ideas, but required.
That's the claim. Required for any system that wants to reliably measure trust. It's not a design choice, it's fundamental. Any working system would apparently have to converge on this architecture.
Okay, interesting. What's the first property?
Property 1, orthogonal categories. Mathematically, they define this with a correlation coefficient, rho being less than 0.1. Super low correlation.
Orthogonal, meaning independent, like measuring separate things.
Exactly. Independent measurement dimensions. Think of it like diagnostic tests for an illness. You need separate tests for different factors, right? Not just a general feeling unwell score.
So you can isolate the source of the problem. If one category drifts, you know it's that category, not something else messing up the reading.
Precisely. It prevents interference between measurements. You get clean signals. The patent apparently proves this mathematically.
That sounds powerful. But how realistic is it? Aren't things in complex systems always kind of interconnected? Like performance affecting security or documentation lagging behind features?
That's a really good question. It's not about the system components being totally separate in reality. It's about the measurement categories being designed to be independent.
Ah, the way you measure them is independent, even if the things they measure interact.
Right. It's a shift in how you build the measurement framework itself. It promises much higher diagnostic precision. You're not chasing ghosts because your sensors are interfering with each other.
Okay, that makes more sense. What's property number 2?
Property 2, unity architecture. This goes back to the map is the territory idea.
Right, the direct semantic to physical link.
Yeah. It means there's no translation layer between the measurement system and the actual system state that could introduce errors or distortions.
You're looking directly at reality, as mapped by the system itself. Absolute fidelity.
That's the idea. Eliminates measurement error from abstraction or interpretation.
Okay. And the third property?
Property 3, multiplicative composition. This is how overall trust is calculated. Instead of adding scores from categories, you multiply them. Trust equals the product of all category scores.
Multiply. Why is that so important?
Because it captures emergent risk. Think about it. If you have 10 components and 9 are perfect, score 1.0, but 1 is terrible, score 0.1.
An additive model might still look okay overall. 9 out of 10 seems good.
But multiplicative.
Yeah.
1 by 1 by 1 by 0.1 gives you 0.1. It tanks the overall score, reflecting that one critical failure can compromise the entire system.
Ah, like the weakest link idea. It captures systemic risk much better.
Exactly. Simple additive models miss that. This multiplicative approach is apparently key to the huge performance gains they claim, like 100x to 1,000x better alignment measurement. It sees failures traditional methods might overlook, like when individual parts work but their interaction causes a problem.
So these 3 properties, orthogonality, unity, multiplicative composition, if they're mathematically necessary, what does that imply about current AI safety tools that, well, probably don't have them?
Yeah, the implication is pretty stark. The sources argue that existing methods like static rules, testing based on samples, correlation analysis, which falls apart when data shifts, purely reactive monitoring.
The stuff a lot that people are using now.
Right. They are fundamentally mathematically incapable of reliably measuring AI trust because they lack these properties. It's like using that rubber ruler. You get a number, but what does it mean?
So if they can't reliably measure alignment,
Then they can't reliably demonstrate compliance either. Which, with things like the EU AI Act coming online, is a massive issue. It's not just about building safe AI, it's about proving it.
okay, this theory, the math, the metaphors, it's compelling. But does it work in practice? Can they actually show it? delivering results.
Well, this is where the sources offer something quite unique. They call it the grade C demonstration.
Grade C. That doesn't sound great initially.
No, but that's the point. It's IntentGuard are measuring its own code base, a research code base, moving fast, not fully polished.
Eating their own dog food, so to speak.
Oh,
or
right.
maybe taking their own medicine.
Exactly. And the C isn't failure, it's validation. It proves the system works on real-world messiness. It found thousands of units of actual trust debt in their own code.
So the system accurately diagnosed its own misalignment. That's actually quite convincing.
It really is. It shows this isn't just theoretical. It catches the kind of drift that happens in real projects. And the report they shared, it was generated today, September 1st, 2025, so it's current.
And looking at the interface they provided, wow. Okay, qualified trust debt grade, C confirmed.
Yep.
True trust debt.
Yeah.
With 1611 units, that's the measure debt, right? Part of a larger detected total.
423 units detected in total, yeah. 1611 is the specific highlighted value.
And here's that orthogonality score, 13.5%. Now, you said the patent requires less than 1% for true orthogonality.
Right, so 13.5% is, well, it's not good orthogonality.
But the system flagged it. It correctly identified that its own measurement categories were too correlated, degrading performance. That's strong validation of the measurement itself.
Absolutely. It proves the diagnostic works. We also see self-consistency. Poor. And measurement points. 225. Lots of data points.
Then there's this balanced asymmetric architecture with an asymmetry ratio, 3.51x. What's that telling us?
That number is fascinating. It means basically for every 1 unit of documented intent, they were building about 3.5 units of reality, of code or features.
Which sounds exactly like a research project moving fast. Lots of building, documentation, maybe lagging behind.
Yeah. Precisely. It quantifies that common scenario. It's not automatically bad, but it's a measured reality of their development pace and the resulting documentation or alignment debt. It gives you a hard number for that drift.
But it's not just about the grade or the ratio, is it? It's about finding specific, fixable problems.
Exactly. Actionable insights. Look at the dense matrix coverage. They say every cell tells a story. It maps the whole semantic space.
And you can see hotspots, right?
Yeah.
Areas with high drift, like implementation X core or data X core, showing big numbers.
Yeah, those hotspots indicate hidden connections, dependencies in the code that aren't reflected in the intent, breaking that orthogonality we talked about.
And it finds specific issues.
Yes, through real-time drift detection, it gives plain language alerts like implementation depends on core, but docs don't mention it. Things that, consultants might charge a fortune to find eventually.
And it even uses AI to help analyze.
Right. AI-powered cold spot analysis. There's an example using Claude AI. It looked at Performance X documentation and found, basically, performance tweaks were made, but never documented for users.
And did it suggest fixes?
It did. It recommended specific actions, like adding benchmarks to the README, creating a performance guide, even estimating the effort involved. Super practical.
Plus, there's a history view.
Yeah, the trust debt evolution graph shows how the debt changes over time. Is it growing, shrinking?
Oh.
It lets you potentially predict issues before they blow up.
And all this is driven by that underlying formula.
That's right. The patent-based trust debt formula. It looks complex, but the key parts are how it penalizes the difference between intent and reality quadratically.
Meaning small deviations get amplified quickly.
Exactly. And it factors in time and how old the specification is. Older specs plus more time plus deviation, rapidly growing debt. It creates this strong push, a forcing function, to fix misalignments early before they become huge problems.
Okay, so this seems really powerful for code bases. But the bigger ambition you mentioned is AI systems. How does this scale up?
Well, the core idea, the mathematical foundation, they argue it translates directly.
So intent for an AI would be?
Things like its business objectives, its ethical rules, the values you want it to align with.
And reality.
Its actual behavior, its outputs, its decisions in the real world.
So the same measurement principle applies.
That's the vision. The enterprise sauce version they're planning will add things like real-time AI monitoring, continuous tracking of that alignment.
And you mentioned compliance dashboards.
Yes, crucially, specifically calling out EU AI Act reporting. With enforcement starting August 2025, that's not far off. Having automated mathematically grounded reporting, that's potentially huge.
And insurance risk.
Actuarial grade risk quantification. turning AI risk from a vague worry into a number an insurer can actually work with.
So this moves way beyond just good coding practice. It's hitting legal requirements, financial risk management.
It really becomes a market and legal necessity. That EU AI Act is a major catalyst. You need provable trust.
Which leads to what they call the inevitable argument.
Yeah, the argument is trust debt wasn't invented. It was always there, just invisible, unmeasurable. IntentGuard just revealed it, made it computable, proved its mathematical necessity.
So now that it's visible,
It becomes inevitable. Developers will compare scores social proof. Enterprises need it for compliance, for risk. Regulators will demand it. Insurers will require it. The market forces all point one way.
it sounds less like a product launch and more like they're trying to define the basic science of AI trust.
That's a great way to put it. It's a race to establish the physics, the fundamental laws.
And the winner doesn't just get customers.
They get to define the standard, the language, the metrics, the certification for AI safety. That's an enormous first-mover advantage, creating a lasting competitive edge for companies that adopt this mathematical approach early.
Wow. Okay, we have covered a lot of ground today, a really deep dive into IntentGuard and this whole concept of trust debt.
We certainly have.
We explored the map of thought, that intuitive picture, and the much more visceral herding cats metaphor.
Capturing both the goal and the struggle.
Then we dug into the math orthogonality, unity architecture, multiplicative composition, why they're apparently necessary, not just nice-to-haves.
The non-negotiables for reliable measurement.
And we saw how even a grade C report on their own system provided really valuable, actionable insights. Proof in the pudding, almost.
Yeah, the validation through self-application was pretty compelling. So the key takeaways, I think it's the urgent, growing need for measurable AI trust. You can't just hope it's aligned anymore.
Especially with the regulations coming.
Exactly. Then there's the innovation here, basing it on a mathematical foundation, not just heuristics, and the huge implications that follow: compliance, insurance, truly responsible AI deployment. It's about building trustworthy systems by design and proving it.
So for you listening, what does this all mean? If you're involved with any complex system code, AI, even big projects where what you intend needs to match what happens.
Which is pretty much everything important.
Right. This deep dive suggests that without a rigorous mathematical way to track that alignment, you might be navigating blind. You could be accumulating this hidden trust debt without even knowing it.
Until something breaks.
Yeah. Which leads to a final thought, maybe a bit provocative.
Let's hear it. In this world that's becoming so reliant on complex, often autonomous AI, if we can't precisely mathematically measure its alignment with our intentions, with our values, how much can we genuinely trust it? And maybe more critically, what kinds of unforeseen debts are we racking up right now, silently, without ever really grasping their true scale or the impact they might have down the road?